All right, we're going to do a little different today. So you're going to take notes with me on this, and then we'll go over it next class when I'm here. So a linear equation is an equation. Ooh, this is hard to write on. That when graphed makes a straight line. That's really hard to write on. It's going to take some practice. All right, x-intercept is the point where the line crosses the x-axis. So the point where the line crosses the x-axis. Y-intercept is the point, I bet you can guess, where the line crosses the y-axis. The point where the line crosses the y-axis. All right, so here in this example, this is pretty easy. You are choosing convenient. Ooh, I don't know what's happening. I clicked on something, sorry. Okay, you're going to choose convenient, easy, and xy values. So here are the values I'm always going to choose. -1, 0, 1, and 2. You do not have to choose those, but if you choose different ones, then you're going to have different answers when you go to check it with the key. So we will always use -1, 0, 1, and 2 when we're given those choices. And this is where you're taking that y equals -x plus 8. Don't forget that negative there. Remember parking spaces. So I'm going to put negative, my parking space, plus 8. So I'm filling in with that -1 from my choices over here. So -0 plus 8. -1 plus 8. -2 plus 8. And then you solve it. So use your calculator. A negative makes a positive. So 1 plus 8 gives me 9. -0, no such thing. So 0 plus 8 is just simply 8. -1 plus 8 gives me 7. And then -2 plus 8 gives me 6. So step 1 was choose the convenient variable or convenient values. Step 2 is to substitute them in. Use those parking spaces. Let's make a note. Parking spaces. Simplify to find your y's, and then we write it as ordered pairs. Do not forget parentheses again. So -1 and 9. Ooh, my pen's not working right. 0, 8, 1, 7. Do you see where I'm getting those ordered pairs from? So my x's are from the x column. The y's are from when I solved it and got the y's. Now we graph it. We graph it just like we graphed ordered pairs. So I go over to -1, up to +9, I put a point. I go over to 0, up to 8. Over to 1, up to 7. Over to 2, up to 6. And now look, if I connect them, they make a straight line. This is like your check. If it does not make a straight line, you did something wrong. So you know that you've done it correctly if it makes a straight line. Okay? All right, next page. Let's do number 3 together. So we'll do number 3. So you see I'm plugging in 0, so I have -2 times 0 plus 1. -2 times 1 plus 1. -2 times -1 plus 1. -2 times 2 plus 1. I solve it. 0 plus 1, -2 plus 1, +2 plus 1, and then -4 plus 1. So my ordered pair is 0, 1, 1, -1, -1, 3. My negatives are looking like dots, I'm sorry. And 2, -3. So the domain, don't forget, remember Dr. XY? I'm going to write that here. So domain goes with x's, squiggly brackets, 0, 1, -1, 2, squiggly bracket. My range are my y's, 1, -1, 3, -3, squigglies. And then I graph it, 0, +1, 1, -1, -1, +3, 2, -3. Connect them to make a straight line. Good? All right. Let's look at number 6. That's a special case one. Number 6. So it says y is 4. So guess what I do? I put 4 every single time. Does not matter. I'm going to call this a HOI. Next year, you're going to, if you go to algebra, you're going to hear HOI. Horizontal, zero slope, y on the y-intercept, y equals. So it would be 0, 4, 1, 4, -1, 4, -2, 4. So it doesn't matter where I am at on the x, everything will be at 4, and it will just go horizontal on the 4. Remember, for my range, I only write that number one time, and then the domain would be my numbers. Let's jump ahead to page 17. So on page 17, these are some similar SOL questions you might see. So if I'm looking, let's look at number 10. So which ordered pairs are on the line of the function y equals -3x minus 1? So you are substituting in the x and the y, and you're solving to see if it works. So for A, I would say -3 times -4. So -3 times -4. What's that give me? +12 minus 1. Does that give me 11? Yes, so that works. I'm plugging in my x and my y. So for this one, -3 times 3 minus 1. That gives me -9 minus 1 is -10. So that one works. Let's try C. -3 times -2. Whoops. I don't want to do that yet. There we go. Minus 1. So that's -6. Or excuse me, +6 minus 1 is 5. Yep, that one works. And last one, -3 times 5 minus 1. That's -15 minus 1. Does that give me 10? No, so that one does not work. So you got to watch. It said which ordered pairs, so it might be more than one. So you're substituting in. The rest is pretty straightforward. We'll look at number 21. So it says, what is the range if the function y equals 5x plus 1, if the domain -1, 0, 1, and 2? So same thing. You're plugging in 5 times -1 plus 1. 5 times 0 plus 1. 5 times 1 plus 1. And then 5 times 2 plus 1. So that gives me -4. That gives me 1. That makes 6. And that makes 8. So here in my range, I would put -4, 1, 6, and 8. And then here I would put -1, 0, 1, 2. -4, 1, 6, 8. These are all pretty straightforward. Go back here. So let's look at 27. So for this one, remember, this is where we're finding points exactly on the line. So this would be 0, 3. If, like in number 26, it asks for domain, then I would list 0 as my domain. 6 zeros, exactly on the line. 2, 2 is exactly on the line. 4, 1 is exactly on the line. So if it asked for domain, I would write 0, 6, 2, 4. Range would be 3, 0, 2, 1. skip number 34. We can't see the equation for number 34, so skip. All right, so now it is time for Socrative. So you're going to do your Socrative. I will see those results. I'll see who needs help for next class. And then you can finish up these pages. You have up to page 24 for homework. And then if you finish that, what do you do next? Alex. So after Socrative today, it's just to get me the results. Then you'll do the practice pages and then Alex. All right, do what you need to do. Be quiet. Don't have the sub write your name down. And I will see you on Wednesday.